So today, we're going to pull back the curtain on the secret blueprint that powers pretty much every single app you use, the database schema. It's the invisible structure that keeps our entire digital world from falling into complete chaos.
I mean, really think about it for a second. How does a huge website like Amazon, or even your bank, keep track of millions of people, products, and transactions all at the same time? Well, the answer isn't magic. It's just a really smart plan. And that plan is the schema.
And this right here is the difference it makes. Without a schema, your data is just a jumbled, chaotic mess where you can't find anything. But with a schema, it becomes this perfectly organized library. Every single piece of information has its own special place, which makes it easy to find and super useful.
Okay, so let's get right to the heart of it. What exactly is a database schema? Honestly, the best way to think about it is like an architect's blueprint, but for data instead of a building.
You see, just like an architect would never start building a house without a detailed blueprint, a developer would never build a database without a schema. It lays out the structure, the rules, and all the connections before a single byte of data is ever stored. The key thing to remember is this: a schema is all about planning ahead.
And look, this isn't just for massive tech companies. Any system that needs to store information, from your school's student portal to your favorite online shop, starts with a really well-thought-out schema. It's the foundation that everything else is built on top of.
So, if the schema is our big blueprint, what are we actually building with? Well, the first and most fundamental piece is something we call a table.
And you know what? If you've ever used a spreadsheet like Excel or Google Sheets, you pretty much already get what a table is. It's simply a collection of related stuff, all neatly organized into rows and columns. It's that simple.
Here's a perfect example, a student's table. You can see right away how simple and clean this is. Each row is a different student, and each column holds one specific piece of information about them: their ID, their name, and their age. It's just organized common sense.
And just for fun, here's a little peek under the hood. To actually create the blueprint for that table, a developer would write a simple command like this one in a language called SQL. It's basically just saying, "Hey, computer, create a table for me called students, and make sure it has a spot for an ID number, a name, and an age."
Okay, so we get the table as the big container. Now let's zoom in on the parts that make it up, the columns. This is where we get into the specific details.
Think of each column as a labeled container. The name column, it only holds names. The age column, it only holds ages. This is all thanks to something called a data type, which is just a fancy term for a rule that makes sure the right kind of information goes into the right place.
Here are a few super common data types you'll see everywhere. Int is just short for integer, for whole numbers. Varchar stands for variable characters, which is just a technical way of saying text. And date is, well, you guessed it, for dates. These simple rules are great because they prevent silly mistakes, like putting someone's name in the age column.
So, we have our tables and our columns. But the real power of a database, the thing that makes it so amazing, is connecting all that data together. This is where relationships come into the picture.
This brings up a really important question. Let's say we have our students table, and then we have another table for courses. That's great, but how do we know which student is taking which course? We can't just cram all the course info into the student table. That would get messy really fast. We need a clean way to build a bridge between them.
The very first step is to give every single row its own unique ID. This special ID is called the primary key. For our students table, that student ID column is the perfect primary key. It's just like your own student ID or driver's license number. It's guaranteed to be unique to you and only you.
And now, it's time to build that bridge. We do it with something called a foreign key. A foreign key is just a column in one table that holds the primary key from another table. It's the little connector, the pointer, that creates the link.
Let's see exactly how this works. Our students table has its primary key, student ID. Our courses table has its own primary key, course ID. So to connect them, we create a third table. Let's call it enrollments. And each row in this new table is just a simple link. It just holds a student ID and a course ID. That's it. It elegantly connects one specific student to one specific course. It's a really powerful way to handle complex connections.
Okay, we've got the theory down. Now for the really cool part, seeing how this stuff applies in the real world, all the way from your own side projects to the biggest companies out there.
Seriously, you can do this yourself right now. Think about a hobby, maybe your book collection. What info would you want to track? Title, author, genre, right? Boom, those are your columns. The table is your books table.
And just like that, you've designed a basic schema. It's really that straightforward to start thinking this way.
And what's wild is that these exact same principles are what power the world's biggest systems. E-commerce sites have tables for customers, products, and orders, all linked up. This organized structure is exactly what lets them handle millions of transactions reliably and grow bigger without collapsing into a total mess.
All right, let's bring it all home into a quick summary of everything we've learned about being a data architect. So, to recap the big ideas, tables are our containers, basically like individual spreadsheets. Columns are the specific categories inside those spreadsheets, each with its own rule. And, most importantly, relationships are the bridges we build to connect all our different spreadsheets into one powerful, amazing system.
So why does all this matter so much? Because a good schema is what transforms a chaotic pile of data into a reliable, organized system. It makes sure your data is trustworthy, and it provides that solid foundation that every single great application needs to be built on. And that leaves us with one final thought. Data is everywhere in your life, from your phone contacts to your music playlists. So the next time you use an app, just take a second to think about that invisible blueprint holding it all together. It kind of makes you wonder, what's the blueprint for the data in your life? Thanks for tuning in.